All right, let's get this started. So, four new pull requests this week. One is from Igor. It's an evolution of his previous work looking at trying to figure out how to better utilize device space for fast devices in BlueStore. Um, so I have not looked at how this is different than the earlier version, but let's see, is Igor? Yeah, you're here, Igor. Do you want to say just quick how this kind of improves on the old one? I think you're muted.
Yeah, sorry. So actually it simplifies things a bit by utilizing current path model for RocksDB, has just slow and DB paths. And instead of getting level from RocksDB or using some tricks, it uses just these flow and DB levels, virtual levels, and again makes the same matrix per level per device usage and tracks how space is used and then tries to allocate extra space from DB volume if possible. So we don't need any changes to RocksDB. We don't need any changes to existing path model, and etc.
Nice. That's fantastic. Yeah, I will try to look at that at some point here soon. I'll be better than the other PR of yours that I need to look at. Okay, cool. That sounds great, Igor. Next one is one from Sam that's related to the stuff that we're going to talk about, I think. Do you want to talk about it now, Sam, or do you want to just fold it into your other stuff?
I'll just mention it as part of the other stuff.
Okay, sounds good. Let's see. There's Majian Peng has a pull request to narrow down the locking in BlueStore, but it's a little scary. I think Kifu's trying to understand the rationale behind why it's okay. And we're waiting, I think, to hear back from Majian Peng on that. Let's see. And then there's this other one by, I'm afraid I won't say it right, but I think Shishing, maybe? That's read data portion of pushing object in batch. I don't even remember exactly what this does, but it was claimed to be faster. And I think Kifu was planning on trying to review it in more depth. So,
Yeah, it's doing one single or fewer reads rather than a bunch of tiny reads for different extents. So it should be much faster.
oh, nice. Okay, cool. Well, that's exciting. So let's see. Okay, a couple things closed. CBT stuff for Crimson testing. This deferred IO notify and locking optimization didn't actually do a whole lot. It sounds like, but yeah, every little bit helps. And then this other one from Igor, remove some lock acquisitions in Common Finisher. There were a couple that were updated, well, actually more than a couple that were updated this week. Sage's 64K Alex size one is in testing. So that's basically an evolution of a couple of different other ones that Neha has been working on. This one is different in that it leaves the larger Alex size for RocksDB, whereas on the shared device we use a smaller Alex size to avoid fragmentation-related space usage, or space amplification, maybe I should say. Let's see, there's a couple of other ones here related to Finisher, or at least one related to Finisher. Majian Peng is in testing. Adam's stuff is continuing to be worked on. Any updates, Adam, on your stuff?
I have smashed the entirety of iObject down into a small number of commits for ease of reviewing. And that part there should be ready for anyone who would like to review it, to review, hint, hint. There is currently a slight problem where the change I made to allocate less in the client impacts the ability of Crimson to compile, and I'm going to push a change for that fairly soon.
Cool.
Thanks,
All
Adam. I'll
right.
try to take a look at that next few days or week.
Thank you. I would appreciate it greatly.
Sure. Long series, so I can't promise that it'll be fast, but I'll try to at least glance over it.
All right. Let's see. Multi-site sync fairness, that just got a tracker updated. Nothing else, I think. Or tracker created, rather. Let's see. This MDS cache memory limit work. I think Patrick is kind of trying to figure out what's going on with it. Hopefully we can still get in for Octopus, but it's been moving a little slow, I think, or just hasn't gotten as many updates recently. Blue Store allocator aging tests. This is a really old PR that Adam was working on a while back, and it looks like he's other Adam is working on, and I think he's maybe resurrecting that to hopefully get it in. And then this week, no movement on the sharding work, but hopefully that will continue to progress. I'm watching that very closely to see if I should try to get my double cache avoidance, ONode double caching avoidance PR merged now or after that. But in any event, we'll see how it goes. It was just the same variety of other stuff this week that has been kind of on the back burner previous weeks. The IOU ring stuff hasn't moved any. Some other random things here. I think that's about it. So, Sam, why don't you take over and tell us what you've been working on?
All right, one sec. Is this showing up?
I see a cursor and a black screen.
Okay, one sec.
There you go.
Okay, so what I've been looking into so far is, well, the end goal is we want quality, the QoS stuff in the OC to work, right? So for that to work, Blue Store needs to not accept more than the amount of I/O it needs to actually hit essentially its throughput goals. So the throttles that currently exist in Blue Store, there are two of them. One throttles the amount of I/O that is accepted into Blue Store, but not committed yet. So the part that hasn't gone through the KV sync thread. The second one is the throttle that controls how much has gotten through the KV sync thread, but it has not yet had its deferred write processed. So it's the deferred throttle. So we want a more accurate understanding of what those throttles should be set to ensure that Blue Store gets reasonable throughput at different I/O sizes, but does not accept so much I/O that the next thing taken out of the throttle has a lot of latency. Because once we have, with some architectural changes in the OSD, we can modify it so that when we get a high priority I/O from a higher priority client, for instance, the latency for serving that will be relatively low because the BlueStore won't have already committed to doing a bunch of low priority stuff. So to get better data on this, I added a whole bunch of trace points to BlueStore that allows tracing or sampling of specific IOs, specifically all of the initial conditions for the IO when it starts, what the current throttle values are, a bunch of stuff from RocksDB, and a few other things. You can see the details in that pull request. And a few random Python scripts I've added to the CPT Git repository for lack of somewhere better to put them. So each of these data points is a single IO taken from running random 4K writes against 512 gigs of data, 4 meg objects using the Ceph or the FIO Ceph object store backend. And it looks to me here like, at least for 4K, we only need about 1 IO of KV throttle. The sizes here are misleading. The 1.0 here is 10 megs, but the throttle cost per IO hard disk value for BlueStore defaults to a little more than half a meg and is here 1 meg. So the latency curve here starts to go up substantially after essentially 2 IOs. Similarly, if you look down at the throughput graph, we already have most of the available throughput at 1 or 2 IOs. So we actually get very little benefit from doing a lot of stuff for hard disks. Does that make sense? Any questions? You guys see the graphs?
Yep, we can see them, Sam. So based on what you were just saying, it sounds to me like the general theme here on hard drive right now is that you don't benefit much by having lots of concurrency against the hard drive, which kind of makes sense, right?
But we do benefit from having it in the deferred throttle. So if you look at the second column of graphs, we don't see big spikes in latency until like 30 megs of deferred throttle. And there is some modest increase in throughput associated with that. So somewhere in the middle there is more appropriate. The only challenge is that it's hard to, well, if we look at the 512 numbers, we do see some increase in, or some benefit from having multiple things queued, probably because of overlapping the AIO write with the KV sync thread write. But similarly, low concurrency is the sort of order of the day here. There's a little bit of a trick in that it's hard to get the right throttle cost to match up between 4K and 512K here, because in both cases the throttle cost per IO actually dominates. So we may have to think a bit about how we think about the accounting between small and large IOs. Yeah. But again, same deal here. Deferred throttle doesn't matter here because 512K writes don't use it. So, any questions on hard disks? So the hope here is that as we do more of the QoS stuff and try to improve BlueStore's latency variability in general, the trace points will be useful in looking into individual IO behavior. All right, so NVMe is a little more interesting. Concurrency actually matters. It looks like up to, what did I say? Up to about 500K, or at about 500K of throttle, which is about 4,000 IOs here, because the cost per IO on SSD is set to 8K in this case. We get pretty much the full throughput we have available to us, which in this case is about 27,000 IOPS. And there's a large jump in latency past that point, so that's probably what we want. And that's much, much lower than the throttle value set in the defaults. In fact, the throttle value set in the defaults is, I believe, lower for NVMe than hard disks, and it should be the other way around. NVMe actually benefits from parallelism. And with 512, same kind of thing. Some additional throttle value is valuable, up to perhaps 3 IOs worth of throttle, but not much past that because 512 pays enough to largely saturate the device. So that's all I've got. Questions? So I think the next stage is to embed these trace points into CBT, get better data, and very likely improve the defaults. But the longer term goal is to make these things self-tuning, because I think the actual values will differ substantially between different device types. For instance, with the hard disk values, this curve looks completely different if you don't have an NVMe database. Like, it's not similar at all. They're essentially not the same device type.
Does it end up looking more similar to the 512 curve at that point, due to the lack of speed up for deferred?
It looks, well, hang on a second. We'll go grab the graph. So it's a lot less sensitive to, or generally speaking, to, yeah, the latency is a lot less sensitive to the throttle cost. It's just much, much higher. And same deal with throughput. So it still doesn't benefit much from parallelism, but at least the latency doesn't spike as rapidly, if that makes sense.
Yeah, both the curves are relatively flat.
Yeah, it's dominated by the commit time.
So, quick question then: how close are we to being able to make some benefit from the QoS reordering with some adjustments to throttles?
Well, the evidence here is that any experiments we've done in the past with the default throttles were not going to work because BlueStore accepts way more I/O than it should. So the next step is to see how the QoS stuff works if the throttles are set to something appropriate.
Okay, got it.
Does that make sense?
It does, yes.
Yeah. So I guess the way I'm going to do that is by wiring up CBT, or by setting up CBT and then wiring up a couple of different RBD devices with different priorities and evaluate whether one of them with extremely low Q depth gets decent latency while the other is sending a saturation level workload. That I think should be the test.
Sam, I'm definitely the most excited, or was most excited when you started talking about auto tuning it. That's the piece that I
so
think
that's where I started. And that's why if you look at the pull request, it embeds a lot of additional, like, I picked out all of the RocksDB properties that I thought were interesting. Like it exposes the number of current compactions in progress, the amount pending flush, all that stuff. Because I was hoping that stuff would be, along with the current in-flight operations, would be predictive of latency. And as far as I can tell so far, it isn't. BlueStore just has a lot of internal variants. So that's a bit frustrating. But yeah, it's important to make it auto-tuning because this sort of exercise is not something most users are going to do. And I don't think you can make QoS work without accurate throttling.
Sure.
So in your investigation, were you able to figure out where in BlueStore that variance was coming from?
No. It's either device level or RocksDB level, I suppose.
It's not allocator level.
Yeah, no, you're right. It could be that too. That is another direction I could go next, but I think finding out whether the current QoS stuff works at all is probably a better next step.
Yeah, I agree.
Because
There's multiple directions for that. That makes more sense in terms of getting the QoS working.
Well, more and also if the current approach doesn't work at all, then we have to rethink that too. If it does work, then it's just a matter of making the BlueStore site work. That's straightforward. Well, it's not because we don't know how to auto-tune it. But
Sam, when you mentioned device, CBT does run Clockdle in the background during runs, and you can go and look at the device queue lengths and service times, which, it's not like, I think the granularity is like 1 second, so it's not super, fine-grained, but it might give you something.
Yeah, I'll need to find I'll have to pull that into the RIO data. I wonder if I can sample that stuff from inside of BlueStore.
Yeah, you probably could.
Yeah, I probably can.
The one thing that I was just thinking a little bit as you were talking is Igor had mentioned possibly resurrecting an old pull request that he had that stores small writes in the database rather than on the block device. So if it's like a 4K write or something, that would potentially change some of this, I would imagine.
You mean so a deferred write that never actually gets written back?
Igor, how were you doing what you were doing in your old pull request?
Well, the idea is to keep small objects at RocksDB level to avoid space amplification at main device, because for RGW using small objects like 1K or 2K, space amplification is pretty high. The idea was to store such objects at RocksDB.
That's a solid choice. It won't be applicable to RBD though, because they're 4 megabytes. Right.
Yeah.
This workload is an RBD-like workload. Is there interest in QoS for an RGW-like workload? Or maybe on a shared OSD situation?
Yeah, there's certainly interest in that, especially for different classes of RGW users or buckets.
Likely you do that at the RGW level, though, right? Because you've already consumed RGW gateway resources.
Yes, but you need some level of OSD interaction to keep those kinds of service levels, right?
Certainly, if you wanted to interact with other non-RGW workloads.
Could you repeat the preamble to that line of questioning?
Oh, I was just asking, are we primarily interested in QoS in the context of RBD, or are we also interested in it for RGW?
Well, yes, both. Also, yes, we are interested in both, I assume. I certainly am. I think the world is.
Right.
So what are your next steps, Sam?
I'm going to integrate the trace points into CBT and do the 2-client experiment.
Okay, cool.
That is now that I have values for what the model should probably be set to, at least on these devices on this node. I'll set up 2 RBD clients, one sending 1 queue depth, writes, the other sending a saturation workload. And the idea is to get the QoS stuff to give the 1 queue depth write latency as though the other client were not present, right? That's essentially what we're going for.
Yeah, essentially.
as it does.
Right. We'll find out to the extent to which that works.
Do you want it to necessarily be the same latency as if the other client was not present, or do you want it to be
same in scare quotes, right?
Yeah.
I mean, there's some trade-off, but it certainly shouldn't be 10 times the default latency, right?
Yes, agreed. I would think it would be some level higher, but not, like crazy higher, right?
Right, and I expect that the degree to which it is some level higher is a trade-off against where you put the throttle values. If you put them so that the latency remains very low for the next thing queued, you give up a little bit of throughput, but that would be an appropriate trade-off for some people. So I think you can actually get it very close to the idle latency value if everything were behaving optimally. At least that should be the goal.
Yeah. Well, neat.
Yeah, it's quite interesting how every device type you looked at use a throttle value that was much lower than the current ones.
Yeah.
Considering so many benchmarks, I just end up disabling the throttles entirely and just to get the maximum throughput out of the booster without regard to latency.
Well, and that makes sense if you're benchmarking, right? But it's not so useful if you're actually trying to do QoS. Because if you're not doing any QoS, then it sort of doesn't matter, right? Then the next layer up is sending what it's sending, and it doesn't care about BlueStore's latency. It only cares about its own application level latency. So whether you do the throttling at the interface level, as we eventually will, or at the BlueStore level, or at just the device level because it's slow, it doesn't matter. It just changes where the stuff is queued. But if you're doing QoS and you're trying to give differential latency to different clients, it actually does matter. And you can't send that stuff to the device until the device is ready to use it. So I think that's why this is the first case where it actually matters. Because before this, throttles were just a way to keep the OSD from running out of memory under high load.
I seem to remember there was some work that was done on looking at the throttles a while back, though. Neha, did you were working on stuff related to some of this, weren't you?
I wasn't working on throttling at the BlueStore level. I was more on the OSD recovery level.
Oh,
recovery
okay.
sleeps stuff.
Okay.
But yeah, we did see that based on the device type, there was a lot of variance in the results.
Do you remember when you were doing that work, did we end up lowering the throttles from what they were previously?
You mean the recovery sleeps?
Yeah, sorry. Yeah, that's right. Did we?
So originally when we had these recovery sleep options, they were blocking, so they were not asynchronous. So we always kept them 0. So I don't know. I mean, like, since they were all 0, people probably never set it to since they were blocking and also they were defaulting to 0. So I don't know what the impact was, but with the stuff that I did, we ended up increasing the sleep for hard disks and the hybrid case where metadata is on faster device to non-zero. And that did help with the overall recoveries performance.
That's right. It's kind of starting to remember now your presentation from back then.
Yeah, I can dig that up and paste it in the chat if you like.
With the throttles actually behaving well, it's possible that those sleeps won't be necessary, although we would need to take into account the read workload.
Yeah, I agree.
Yeah, all those throttles for different background operations are kind of always a kind of stopgap.
Yeah.
If QoS actually works the way we hope it does, then in theory they shouldn't be necessary.
All right. Well, cool. Anyone have any other questions or comments on any of this? Well, thank you, Sam.
Yep.
Super interesting. Oh, and I see Neha posted her.
I'm not sure what the access level is on this doc, but if anybody is interested, let me know. I can create something that is visible to everybody.
Yeah, it looks like you have to be a Red Hatter to see it.
Yeah, that could be the problem.
All right. So Neha, I forget what it was, but earlier this week in stand-up, you had mentioned wanting to talk about something at the performance meeting if we had time. And it looks like we do have a little time. Do you remember what it was?
Yeah, it was the 4K min-Alex size that Igor was investigating.
Ah, yes, that's right. Igor, do you want to recap for the group some of the work you've been doing?
Yeah, I can try. The general idea of this benchmark was to verify if one can reduce boolstorm min-log size safely. Again, to save some space for high amount small GW objects. Well, actually, we have a customer experience issues with this stuff, and well, they are using spinner-only drives behind BlueStore. So actually, the scope of this benchmark is pretty limited. I didn't cover large block sizes or some more expensive scenarios. But anyway, I tried Radha's bench doing write on map and write object using 4K block size, and then Radha's FAO plugin on a bunch of small objects ranging from 1K to 8K and performing full overrides. And actually, I can see that 4K is so the assumption was that 4K min-log size, contrary to default 64K, will produce some performance overhead, and I'd like to estimate how much it is. But surprisingly, it occurred that these settings are even better for, at least for these specific test cases. Sometimes up to 50%. Well, I have some plans to try larger block sizes. So far it was just 1K, 2K, 4K, and 8K overrides, as well as reads and some random writes. That's it. I can share the link, the results. Here it is. Well, I also tried the configuration with NVMe, with DB on NVMe drive, and similarly, there are some benefits from using 4K for the main device. That's it.
So I was going to post two. I've got, this is the same document I shared last week, where this is kind of an offshoot of the 64K BlueFS Alex size work. but also looking at 16K versus 4K min-alloc size, but in the context of NVMe drives instead of hard drives like Igor was looking at. And the last tab has the most stuff in it, but even the first one there, you can kind of see that there was some advantage for 4K min-alloc with doing OMAP testing. But the last tab, the RBD iteration tests, is the one where it's basically looking at a bunch of different RBD workloads ranging from 4K to 128K to 4 megabyte reads, or RAND reads, RAND writes, reads, and writes. And it does multiple iterations of those tests so that after the first iteration, everything starts getting kind of fragmented and stuff. But the result of that was basically that it looked like in definitely in some cases having a 4K min-alloc size did show benefit. Not necessarily in all cases, but for certain kinds of write workloads, especially like the 128K sequential write workload. Oddly enough, in the first and the third iteration, it showed really significant performance increases, but not in the second, which I'm not quite sure about. But anyway, I think the gist of it, at least from what I looked at, is that it's not necessarily worse. And it sounds like for Igor's tests, it was better. So the big advantage, right, is that regardless of performance, is that you don't end up with a lot of space amplification for 4K object workloads through RGW. And that's really the big win, I think, in all of it. So if we can do that, it'd be really nice. Igor, I think that was the same reason you guys were looking at it, right? You had people that were suffering from the space amp?
Absolutely.
Matt, do you guys see that with any users that you've interacted with, that they're suffering from space amp due to small object writes?
I haven't heard it discussed, no.
Okay.
Abhishek has mentioned some of their customers are seeing it.
It wouldn't surprise me now that I didn't for a long time I didn't think anyone was actually writing out RGW objects that were smaller than like 16K, but it's come to my attention people actually are doing that. So
Certainly good to fix.
it used to be that it was significantly slower. So we made a judgment call and trade-off, but it seems like at this point we're fast enough that with a small min-alloc size that we probably can do it. So Josh, if we change this, I guess we would need people to observe the old setting until the OSD is rebuilt or something, I guess, right? Would that be kind of the idea for how we would approach it?
Yeah, I mean, the settings currently are stored persistently, so that wouldn't be an issue, I believe. You can correct me if I'm wrong, but I believe that BlueStore is just reading that setting off of disk, and so the new configuration wouldn't actually take effect unless you did do a reset of the store entirely.
Yeah. Yes. Sorry, I should rephrase my question. We wouldn't need to make any kind of like upgrade thing, right?
Oh, I see what you're saying. I think any kind of upgrade thing could probably do the same thing that a BlueStore conversion upgrade in general would do, which would be just reprovisioning OSDs for any of these kind of major format changes where we can't only change like a portion of things, but everything.
So we've got a little bit of a window then before Octopus. We could change it now. I mean, It would be pretty
It's
easy.
definitely worth trying. I guess I'm curious how this would interact with the recently changes with 64K UFS Alex size for the shared device as well.
I don't have it for just the shared device, but if you look at that last RBD iteration test tab, I do have one of those test results is for a 32K BlueFS Alex size, which should probably be pretty similar to a 64K. It'd be a little bit more overhead possibly.
Sure. Okay, cool.
And it looks really similar to the others, at least for RBD. A little slower than using a much larger one for like random writes.
Mm-hmm. I guess what I'm wondering is more than the performance hit would be if we could get into a situation like we got into before with Stupid Allocator, where the BlueStar space fragments enough that 64K would no longer be available for BlueFS to use.
I see.
Or if the allocator is good enough at avoiding fragmentation that it's unlikely.
I think any time that we have it, the BlueFS Alex size be larger than the min Alex size, we run into the possibility of that, right?
Yeah, it's certainly not zero. I'm just wondering if it's like 1% or 0.001%, right?
Yeah.
Is there some like common pathological workload that might generate fragmentation somehow? That level.
It would probably depend on how much you like do tiny writes to the RBD device, wouldn't it?
I would think so. Igor, is there any kind of pathological workload that you can think of for the bitmap allocator?
You mean the payload which results in high fragmentation?
Yeah.
Well, small overrides, massive small overrides in random offsets.
The small overrides with random offsets sounds like a typical like RBD 4K random write workload.
I need to double check where bitmap allocator starts to search chunks from. If that's from the beginning, then actually the probability of this situation is much less than comparing to if it uses the whole in round robin strategy or something like that.
I think Adam Kupchik was saying that it was searching from the beginning of the device.
So, well, then massive overrides with near to full device like that.
Well, if the device is near to full, I guess I'm not as worried about it at that point. Yeah. I guess, like you said, Mark, now in the Octopus timeline is perhaps the time to try things out and we can get more testing on it and see if we do run into any kind of crazy scenarios.
Yeah, the thing I was most worried about is the stuff that Igor's testing, and it sounds like it's faster. So that's, I mean,
yeah,
that's huge.
Well, as far as I understand, the final idea was to use just a single allocator for both main device at BlueStore and slow device for BlueFS, which means we will have single alloc size for both cases. Maybe we need to do the additional benchmark when we have such a setup, and I'm not sure if the performance drop is going to be that large, actually, between 64K and 4K. But no, this needs some investigation, definitely.
If it came down to having to eat the space amplification to get a single allocator, or have like a really low value that also then has like a performance impact, I would say that I'm not convinced that we do want just a single allocator, but maybe I'm wrong about that.
Well, I think the evidence isn't the evidence showing that a smaller min-alloc size is desirable.
Min-alloc size, but not necessarily BlueFS alloc size. We've seen some evidence that. Oh, go ahead, Josh.
I was going to agree with you, Mark. If there is like a very large hit to performance or space amplification, if we have to have a single allocator, then we might want to consider the current scheme with the dispatch of only making them making the BlueFS alloc size the same or similar for the shared device, and potentially keeping it larger rather than having one allocator. Just like with all these different booster optimizations and performance changes, really just need to measure things and figure out what makes sense, right? What makes sense, right? Also kind of curious how this interacts with some of the other ongoing optimizations in BlueStore. If for example, the elite range stuff has any effect, as well as the sharding. I think we've tested each of these things kind of individually so far, but once they're all kind of merged, it'd be interesting to see the aggregate effects.
Yeah, I agree, Josh. I think once we throw all of this together, there's going to be a lot of new kind of investigation that will be needed to understand where we kind of land with it all.
Yeah, exactly.
All right, well, cool. Anyone else have anything that they want to talk about this week before we wrap up? All right, well then, good meeting, guys. Thank you, Sam, for showing us the work you've been doing. Very exciting. Looking forward to hearing more, and we'll reconvene next week. See you later, guys.
Thanks. See ya.
You, ma'am.